Terminology that we are going to be discussing today too is a mathematical sentence that compares values of two expressions using an inequality symbol. And that's called an inequality. Alright, inequalities are anything that we're comparing. Hopefully you guys can remember these from school. A lot of you guys probably have seen these since I'm hoping grade school. But if not grade school, middle school will work. So looking at this, less than. What's the symbol that means less than? Good. And a lot of you guys will tell me that it's the alligator facing away from the first number. Alright, cool. I agree with you that that is an easy way of remembering it. But that is also called an inequality. I think I was pretty shocked by how many people didn't know what the word inequality meant. But the moment I brought up alligators, we knew exactly what it was. So again, it does go back to, you need to know your terminology, but at the exact same time, having easy ways to remember it is awesome, but you need to know the terminology that goes with those easy ways of remembering it. Does that make sense? Greater than is what? Good. It's the inequality symbol. That is, the bigger part is facing the first number. Also, you guys probably have heard it as the alligator eating the first number. Less than or equal to. It includes it. Okay? The biggest thing about this is it includes it. Greater than or equal to. It includes it. If I were to say this, 3 is greater than 3. Is that a true statement? No, it's not. This is not a true statement. Not true. What could make this a true statement is by me saying 3 is greater than or equal to 3. This is a true statement. Okay? Do you see the difference? This one doesn't include the equal sign. This one includes it. Right? What we're going to be doing is actually comparing our numbers. So, biggest thing on this one is knowing some tricks with this. Okay, so first of all, 4/5, I can write 4/5 as a decimal. And again, I can plug it into the calculator as 4 divided by 5, or I can use make it a fraction and change it to a decimal. So 4/5 is really 0.8. Okay, well, what's the square root of 1.3? I don't have that memorized, so I'm going to plug it into my calculator. 1.3, square root of that is actually, let's see, right, yep, is actually 1.140 ... Alright, well, which one's bigger? 1.140 continuing on, or 0.8? Good. So which one's bigger, 4/5 or 1.3 square root? Good. So 4/5 is actually less than the square root of 1.3. Okay, what about this guy? Well, again, this comes down to, hey, 81 is a perfect square. So this is actually 9. Now this negative symbol outside here means that it's the opposite of whatever this is. So what is the square root of 121? Well, 121 is actually a perfect square, and the square root of 121 is 11. And this says the opposite of this, so this is going to be a negative 11. So which one's bigger? 9 or negative 11? 9 is. So a square root of 81 is greater than the square root of the opposite of negative, or the opposite square root of 121. Notice I'm putting the inequality symbol with the actual problem and not with this. To me, this is what I like to call chicken scratch. It's chicken scratch because it's how I'm verifying my answer. Alright, it's chicken scratch because it's kind of like me thinking out loud. What is you know, 4/5 as a decimal, it's 0.8. I'm writing it down so I can remember it. I do not want you putting on your homework 0.8 is less than 1.410 ... If you tell me this, I'm counting it wrong, because that was not the original problem. The original problem was 4/5. Okay? I want to see this. I want to see this. I don't want to see 9 is greater than, because that's not what the problem asked you. The problem asked you square root of 81 and the opposite of. So I'm not going to take this. I'm not going to take that. I want this. Okay? It's fine that you did these. In fact, I encourage it. But I want this. Got it? Okay, so let's do some more. What about this? Okay, I want to order these least to greatest. Well, this is pretty cool, because 4/5 was on our original problem, our problem previous, right? So 4/5 is 0.8, and this guy is 1 point what? Looking at our previous problem, 1.140 ... Okay, what about square root of 0.87? Well, let's figure it out. 0.8711, take the square root of that, is going to give me 0.9333 ... Okay? So I want to order these guys least to greatest. So which number is least? Good, it's the 4/5, because 0.8 is less than 0.9. So in order to do this, I'm going to put it over here. We have 4/5 is my least. What comes next? We took care of 4/5. So now we're left with the square root of 0.8711 and the square root of 1.3. Good, it's going to be the 0.8711. So next up is the square root of 0.8711 and then the square root of 1.3. Notice again how I'm not putting 0.8 or 0.93332 or 1.140 in here. I'm putting my actual numbers from my problem, and that's exactly how I want you to do your homework. I want you to put it with the exact numbers from the actual problem. Not the numbers that you used to figure out the answer, but the numbers that were from the exact problem. Okay, looking at this one, well, we got pi here. What is pi? Pi is, good, pi is 3.14. Pi is 3.14. And it continues, right, because pi is irrational. Okay, so let's look at the square root of 10.5625. I know it's going to be close to 3. How do I know it's going to be close to 3? Good, because 10 is really close to the square root of 9, isn't it? So it is. It's actually 3.25. So that is that. And the cool thing about this one is, do I really need to figure out what 15 over 5.8 is when it's negative? No, because aren't these guys positive? And aren't all negative numbers less than positive numbers? Yeah. So this guy we already automatically know is the least. So negative 5 over 5.8 is the first number. It's because we want to go from least to greatest. So what's our next number going to be? Well, is it going to be pi? Or is it going to be the square root of 10.5625? Well, which one's smaller? Good, it's pi. Not by much, but it is. Because, again, I can look at the one spot, and 1 is less than 2. Therefore, pi is going to be less than the square root of 10.5625. Okay? Again, notice how I'm using the original numbers, not my, what I call chicken scratch, what I call numbers that we actually worked out with. Okay? So this is the correct answer, along with this. If you were to put them in as decimals, if you were to tell me that this was 0.8, and then 0.93332, repeat or continuing on, and then 1.140, continuing on, I'm going to count it wrong. I want this. Okay? Same thing down here. I want these numbers. I don't want the decimal forms of those. No, I don't want the actual decimals of them. Alright, last problem. Jason, Allison, and Bob are comparing how fast they run. Jason runs 8 miles in 48 minutes. Allison runs 6 miles in 39 minutes. Bob runs 2 miles in 14.5 minutes. Order the students according to how they run the fastest. Okay, fastest. Do I want to order them least to greatest? Or do I want to, actually, yeah, it'll make sense to go least to greatest. Because it says, who can run the fastest? Order the students according to who can run the fastest. So again, I am wanting least to greatest on here. Least to greatest. Oops. Maybe help if I can spell. Because isn't the least amount of time the fastest time? Good. So how can I figure this out? Well, I could take 8 over 48. And I can find out Jason's. I can take Allison's. 6 over 39. And I can take Bob's. 2 over 14.5. And I can simplify those and figure this out. So we have 8 divided by 48. So that's going to be 0.1666, repeating. Allison is 6 divided by 39. Hers is 0.153846154. And then Bob's is 2 divided by 14.5, which is 0.13793. So, who actually ran the fastest? Well, looking at this is actually pretty cool because the ones place are all the same, right? They're ones. So now I need to look at the hundredths spot. Sorry, the tenths. The tenth spot is all the same. The tenth spots all have ones in them. Therefore, we gotta look at the hundred spots. Well, who runs the fastest? Jason, Allison, or Bob? Bob runs the fastest. So Bob runs the fastest. Who comes next? Good. Allison. And then Jason. And I expect to see these names if this was a homework assignment. Okay. Again, I do expect to see the work going into this, but your final answer needs to be their names in order. Alright, that concludes 1.3 notes. I hope you guys have a good day.